Hey everyone, welcome to episode 11 on our Linux series. In this episode, we are going to discuss about some of the important concepts with respect to Linux file system, followed by few of the advanced commands which we use in a day-to-day operations. In our previous episodes, we have covered some of the interesting topics on file system as well as Linux as a whole. If you have not watched it, please watch it. There will be a link in the description for your reference. Please feel free to watch it. So in this episode, we are going to cover about some of the important concepts like standard file systems, what exactly it is, followed by what is the IO redirection in file systems, very specifically. And one of the important concept, which is nothing but your wildcards, how it is used. We will try to see some of the good illustrations around it. Finally, we'll try to cover some of the advanced commands like pipes as how it is being used for searching within your file systems. So without any further delay, let's jump into the topic. So what exactly is a standard file stream? So file stream is nothing but you can think it of as a flow of data within your file system. So whenever a program runs in your Linux, data is consistently flowing either into the program or out of the program. Anything which you run starting from your command to script, the data is flowing either from your program or into your program. So that is your file stream as a whole. So Linux standardizes this using three default streams. That is nothing but one is being your standard input. Second is being your standard output. Third is your standard error. What exactly it is? So if you want to understand in a simple way, let's say you are trying to do a conversation with me. As a human body, I need to process whatever you are telling to me. And if you are talking to me or trying to provide me any input, my ear will be the main source of input, which will be passing on that information to my brain. So in that case, ear works as a standard input. Similarly, any command or any program which you are trying to run on a Linux prompt, that is being considered as your standard input, or Linux considered as a standard in as a symbolic name. Let's say I heard what you said and I have to reply to your saying in a whatever you have said. So that particular output I have to provide from my mouth, right? So similarly in Linux, whatever the input you have provided or any program which you have run, that has to come as an output. So that is nothing but known as your standard output. And Linux symbolizes as a standard output, right? So let's say whatever you have said, I didn't like it and I have to reply in a negative way, either talking to you as loud or maybe using some of the negative terms, which I don't like. So that is nothing but processing as a loud, whatever you are talking. Similarly, let's say if you are running some command or program and that has some error in the background and Linux has to process it and it has to tell you that that is not right. So that comes as a standard error and Linux symbolizes it as a standard error. This is nothing but your streams, which is particularly letting you or doing the flow of data within your file system for the any input and output it gives. Now, the second part of the streams is the value of it, which is nothing but a file descriptor of it. So now you might be asking what exactly is the file descriptor, right? So in Linux, all the open files are represented internally by what they are called as the file descriptors. Simply, you can consider it that Linux represent it by a number starting from 0. So all the file descriptors starts from 0 up to 2, and those three values are being covered by your file streams, which is nothing but your input, output, and error. So any program or any file which is getting opened after that, that gets a value of 3 or gets the file descriptor value as a 3 within your Linux or symbolizes within your data flow. What exactly it is, how it is used, we will be briefly covering in our next episodes. But for now, you can consider the descriptor value of all your stream values are 0, 1, 2. 0 stands for standard input, 1 for standard output, and 2 for standard error, right? As simple as that. So now, very important thing is that how you will give the input or out. Linux gives you the output. There are two methods. One is via your keyboard. Anything you give an input is via the keyboard. That is the default value. And any output which is given by your Linux is coming via your terminal. That is coming as a standard output, right? And error, it can come in the form of log file, or most of the time it is given within your command line itself. So let's see how exactly it works. Let's say I want to print something. So for printing anything within your Linux command line, we use a command known as your echo. Let's say I want to print hello world. So when I type this is nothing but an input which I am giving to my Linux, and it will give me an output, which is your normal output. Now, output in the sense this is nothing but you're printing your statement which you have given. So this is about a standard output and input which you perform in a Linux command line. In this, keyboard is the input, which is I let the program to run for printing in the form of echo, and output it has given me in the form of hello world. Whatever the input I have given, that is given. Let's say I want to list a file. Let's say there is no such file, right? So this is normally not a command. Ideally, it should give. Now it should give me an error, right? So this is nothing but a standard error or error output in the form of error message is sent to the standard error, right? So this is how your file streams work in the form of standard input and output as well as standard error, right? Now going back, let's say I want to redirect or change the input where it is coming from and where the output will go from. Now, in this case, by default, the input came from my keyboard and the output is in my screen, and I want to change this behavior which is given by your Linux in a normal form. How I will do that? IO redirection is the method which is used by Linux to change your redirection method for giving or changing your input and output operations, right? So when it comes to redirecting your input and output, Linux uses four types of redirection for changing it. It can be an input redirection, it can be an output redirection, it can be an error redirection, and redirect everything together. So there are four type of IO redirection which works within your Linux. How it works, let's see it in the command line and try to understand in a simple way. I have typed echo hello world to give me an output. Now the screen has showed me the output of it, right? So if I hit enter, it will show me the output within the screen. Now I don't want to give the output within my Linux terminal. Instead, I want to redirect to a file. So that is the first redirection, which is nothing but your output redirection. If you want to redirect the output to a file, we use some symbol like less than followed by the file name. Let's say I redirect it to output.txt. Now the output will not be seen in the terminal. Instead, it has redirected to a file in the form of output.txt. If I do ls-l, I can see there is an output which has been created. And if I want to see, then I can see output.txt. This is nothing but the echo of that command. So this is how your output redirection works, right? So let's say I want to append or redirect the standard output to a file, right? Let's say I want to echo another line, right, to the same output.txt. So if I do standard output, what it will do, it will change whatever the output which has been written. Instead, what I want to do is whatever already has been written, I just want to append the value of this command. So I use double and I followed by the file name I do. Okay, if I do it and I do output.txt, here you can see there's a new line which has been created. So that is a second form of redirecting your standard out to a file. Now, let's say I want to redirect the error to a file. Let's say I am writing the command ls no such file, and ideally it gave me an error previously. Now the same error I want to redirect to a file or to another file. What I do, I use to less than, okay, and followed by the file name. And this file name can be anything. If I do, now the error didn't come. Instead, what it did, it wrote that output to my error.txt. Here you can see. So this is how you redirect any error for a program to another file, right? Now, finally, the last redirect, which is redirect both the standard output as well as standard error to a file. Let's say I am running the command no such file with, let's say, existing file, and I want to redirect the output as well as the input. So in this, what I used a new descriptor value to lesser than followed by &1. If I do, then what it does, it will redirect all the output as well as error into one file where, let's see, if I do cat all.txt, here I can see all the error as well as the commands it has been given to that. So if you want to do redirection of both your output as well as standard error, you can use the command in this form. Now, the question can be why all this redirection exists and why we should use it, right? So that is a common question. Why it has to be like this? Why it has not be like that, right? So it has lot many options, right? So when you try to do shell scripting or you try to do automation, debugging or performance or scaling of your commands, redirection helps you a lot. Let's say you want to write a program and you want to write the output to a file, and the log file you want to write for all your inputs as well as output, as well as you want to type it to a log, right? Log file. So in that case, redirection helps you a lot, and this symbols or commands of redirection helps you a lot doing that, right? And this is how the Linux tools are designed. And most of the Linux command either can do a small job or it can communicate using streams. And streams are normally the glue that makes the Linux powerful. And without this, working with Linux in a powerful way is quietly impossible. So that is why knowing the redirection as well as stream is very important. And we will see more illustration around it in our upcoming videos when we do more projects around it. So that will give a lot of sense, right? So hope you understand it. Move into next topic, which is our wildcards and matching file names, right? Now the question is, what exactly is wildcards, right? So you can consider wildcards are normally a special characters which we use to represent one or more unknown characters, right? And normally in a normal way, they make searching, matching and filtering text much easier, especially you don't know the exact name or the pattern. For example, let's say you have 1,000 lines of logs or 1,000 logs files within your var log directory, and let's say your disk space is full, and you don't have any options to delete everything, but instead you want to do a power search or you want to query in a powerful way so that all the files are not only listed but also it is getting deleted. For example, I want to delete the files which is older than 3 months, one example. Or else let's say I want to delete all the cache related files which is there in the log, or cache logs I want to delete. In that case, you can use wildcards to do a power querying or search or filter or match any pattern for searching a particular file within that directory for querying it efficiently, right? So what are those wildcards? So when it comes to wildcards, there are quite handful of it. There is it is not possible to cover everything, but if you want to know more about it, you can just let me know in the comment boxes. I will try to make more videos around it. We will try to see some of the illustrations but not everything. So when it comes to wildcards, asterisk or star in the form of symbol we cover or try to do it in a regular basis. So it helps us for any number of any character which we want to do. How it works, we will see it. And there is something called as question mark for exactly one character, right? So there are multiple ways. Let's try to see some examples around it. Let's say I have 3 files or multiple files within this directory, but particularly I have a pattern with the name of file 1, 2, and it has an extension with .txt as well as .log, right? So let's say I want to match all the files, or I want to search all the files which has a .txt extension around it. How I will do it? I can do ls-l to see it, but let's say there is millions of files within this directory, but I want to filter few of the files which is ending with .txt. What I do, I use ls followed by a wildcard, which is nothing but asterisk or star followed by the extension, right? So what it does, it will search all the files within the extension .txt using asterisk. Here you can see it has listed all the files which has .txt extension, right? Now, let's say I want to match the files which name starts with file, right? What I do, I can use same asterisk. How I do, ls followed by the file and asterisk. It has listed. This way also you can do, right? Now, I want to list all the files which has a single character of it. Let's say I want to do file followed by single character. For doing that, I use wildcard question mark followed. Okay. So in this, you can see all the files which are single character. It has listed in the form of this. What it means is that file followed by any single letter. In this, single letter is 1. If it would have been 11, let's say I am touching file 11.txt. Okay. Now I run the same command. If I do, that file has not been listed, which means after file name, if any single character I want to match, then I use this particular wild character, right? So that is how we use wildcards in a day-to-day basis. Trust me, it has so many applications and we have so many wildcards. There is no end to it. And there are multiple queries which you can make it for searching through it powerfully. And remembering everything at a straight is not available, not possible. It requires a lot of practice. And while we do more and more practice, we will come across around it. But as a concept, you should know it, what exactly it is, how it is being used, right? So this is a simple illustration to give you an overview. Right. Now, going back, the next concept of advanced command is a very powerful command which we use it in Linux is known as your pipes. Okay. As you have understood in our previous chapters, Linux philosophy is to have many simple and short programs or commands to combine together to produce quite complex results. For example, let's say I want to run multiple programs at a single time, then Linux can help us do that. The main character for which helps us achieve is nothing but your pipes. So pipes, by using pipes, we can combine multiple commands for running or process it together. How it works? You can give command one followed by pipe or vertical bar followed by command two followed by command three. This is how it works. And always remember it works as a pipeline and every process is continued after one another. For example, this will be executed first, this will be executed second, and this will be executed in the third. That is how pipe works in real time. Let's see how it works in a real. Let's say I want to see the history. Okay, so then to see the history in Linux, we use a command known as history. So it will show me all the commands which I have executed in past, right? Let's say I want to search for a command which is starting with ls. So I have executed ls multiple times or else multiple commands which I have executed. Let's say I want to list how many times ls I have done. How I do? I run history followed by I use pipe and I can query a particular keyword using another command known as grep. So pipe can be combined with other command as well, but most of the time we try to query it using grep. So grep is the command which helps us to query a particular keyword. Let's say I want to query ls out of the history of commands. So it will list all the commands, how many times I have used, right? Let's say I want to see the history, right? And I want to grep for the keyword ls, how many times I have used. Now I want to see how many times I have used. So using the word count or number of count, if I want to see, I use a command called as wc or word count followed by -l. Here I can see the total number is 37. Now in this case, what I did, I executed 3 parallel programs together using pipe. So that is how we use pipe for running multiple processes all together in the form of pipeline. So that is how it works. Hope you get it. If you have not, then please feel free to ask your doubts in the comment box. I will be reading all your comments and try to reply each of it if you have not understood any concept out of it. Right. We end today's episode. If you hope you have liked it. If you have felt the same, please feel free to like, share, and subscribe, and put your thoughts in the comment. I will be very happy to read through all of it. That's for today. See you in next video. Thank you.